Hi everyone, welcome to this quick video showing you how to do performance testing with Red Raw Media in Scratch on the Mac. Quick info up front. Like many of you, I'm working from home these days, and so I have to record this little video on my MacBook Pro from 2012, which sadly does not meet the hardware requirements for processing red material using Metal or OpenCL. Specifically, the two GPUs in my MacBook do not have the required 2 GB of memory required for Red GPU support. That being said, Eva from the corporate team of Cinepost in Berlin was kind enough to do a quick screen recording on his iMac Pro. As you can see, this is enough to get real-time full-res playback of 8K Red RAW footage within an 8K timeline, all on an 8-core iMac Pro with an AMD Vega 64 GPU. So let me show you which settings in Scratch you can tweak in order to get the best performance with Red RAW footage out of your machine. Let's start by creating a new project. Call this Red Performance Testing. Create, and leave the default image format to just 8K, which is the biggest common denominator. Hit OK and enter the project. As you can see, the import clips button is already flashing at us, so let's hit that and import some footage. Over here, here's a 6K clip. If I disable select folder, I can select single clips instead of whole folders. Hit open. Now Scratch is asking me whether I want to change the timeline settings according to the clip I'm going to import. Let's hit no for the time being and drop it right here. Now if I want to change my timeline settings in hindsight, I can just grab this clip, drop it in here, and now I have a 6K timeline. Alright, head over to Color Efficts and zoom out a little. You can do that by Alt dragging up and down and space dragging to pan the image around. And over here you have the Red Raw menu. Inside there, what you want to do is probably set this to IPP2 and then head over to the Resolution tab. Make sure that the resolution here is set to full res, and then you can set the show resolution, which is used for pure playback, to any of the options here. Let's leave it on an 8th resolution for now. The process dropdown is used for rendering, so we don't bother with that right now. Now to find out how fast the clip is actually playing, hit Command F1 on your keyboard to bring up the performance graph. So as we can see, we're playing with a steady 24 FPS. If we go to the Settings General menu and hit this dropdown, we can actually set it temporarily to free run and find out how fast Scratch can theoretically play the clip if it wouldn't be limited by the timeline frame rate. 74 FPS. Alright, if we go back to our Red Raw menu and set the Byron resolutions to quarter res, we can see how the playback speed drastically decreases on my 2012 MacBook Pro. Alright, so this way you can test performance in terms of playback with Red Raw Media. Let's have a look at some technical settings. Close the project and head over to the log files. In this folder you will find the Assimilate log, which is the log file of the last or the ongoing Scratch session. If we open that and scroll down a little bit to here, we can find some info on the Red processing inside Scratch. We can see the SDK version and also which GPUs Scratch found for Metal processing and whether they are at all suitable. Mine are sadly not. And the same for OpenCL. More importantly, we can find out the device IDs, 0 for the Intel graphics and 1 for the GeForce in my case, which will become more important once we go to the System Settings, to the Advanced tab all the way over on the right, and type in R3D down here to find the Red settings. And there's 3 settings in here that are particularly important. First is the Red GPU mode. On the Mac, Scratch will by default choose Metal with GPU decode. However, For testing purposes, we could override that to choose metal with CPU decode or OpenCL with CPU decode, or by turning GPU mode off, work 100% of the CPU. Right, next are the GPU devices. By default, Scratch will use the GPU that is not the primary GPU for Scratch, in case of multiple GPUs. This serves for a balanced workload, keeping one GPU for red decoding and debayering, and the other one for grading tasks like blurs, keys, and effects in Scratch. However, in some scenarios, like with daily transcoding, where there is no heavy grading required, it can make sense to enable both GPUs for red. In this case, device number 0 and device number 1. Lastly, we have the metal batch size. This basically sets the number of simultaneously decoded frames per GPU. This is also automatically determined by Scratch based on the amount of GPU memory. However, again, we can override this by dialing in a batch size on our own. Alright, I hope this gives you enough to go on with your own red performance testing. If you have any questions or feedback, please let us know. Bye.